So see friends, in some previous videos we have completed about the mechanical properties of materials. Now in this video we are start with the physical properties of materials. So see guys, what are the various physical properties of materials? Now see, let's see here. First one is density. Density is one of the most popular physical property of material. Then melting point. Second one is melting point. Third one is specific heat. Fourth one is thermal expansion. And fifth one is thermal conductivity. All these five are the physical properties of materials. So see step by step, one by one. So first is density. See guys, now what do you mean by density is? The density is the mass per unit volume of the part. Please see, this is very well known by us. Density is nothing but the mass per unit volume of the part. It is expressed in kg per meter cube. What is the unit of density is? It is expressed, that is its unit is kg per meter cube. For example, density of water is 997 kg per meter cube. If you ask about the density of water, so water density is given at 997 kg per meter cube. So this is the standard formula of density. You can see here, that is, this is the rho, this is the what symbol, this is the rho symbol which is used to denote density. So rho is denoting density. So density rho is equals to m by v. Okay, mass per unit volume, mass upon volume. So m for mass and v for volume. So density's formula is rho is equals to mass upon volume, nothing but density. So what is the definition of density is mass per unit volume of the part. And if you see on this image, you can see the various types of metals are given here, and here their densities are given. Okay, so this is about the density, which is physical property of material. Now let's see what next. Second physical property of material is melting point. Now see guys, what is the melting point? The melting point of a substance is the temperature at which a solid and liquid phase may coexist in equilibrium. See guys, what do you mean by melting point is? The melting point of a substance is the temperature at which a solid and the liquid phase may coexist. Okay, they can coexist in equilibrium, or in other words you can define it in simple words, that is the temperature at which a solid turns into a liquid. Very simple. Melting point means that point at which your solid turns into a liquid. So here you can see, here in this table you can see metals and alloys are given, and in this right column melting temperature of that particular metal is given. So iron has melting point, that is 1535 degrees Celsius to 1539 degrees Celsius. Stainless steel has 1400 to 1420 degrees Celsius. Similarly, copper has 1083 degrees Celsius melting point. Aluminium has 660 degrees Celsius. Nickel has 1455 degrees Celsius melting point. Zinc has 419 degrees Celsius. Tin has melting point 232 degrees Celsius, and magnesium has 650 degrees Celsius melting point. So write this. You can see these metals have these melting points. See guys, what next? The next physical property is specific heat. Please see, next physical property is what? Specific heat. So the specific heat is the amount of the heat per unit mass required to raise the temperature by 1 degree Celsius. Let me repeat, specific heat is defined the amount of heat per unit mass required. See guys, the amount of heat per unit mass required to raise the temperature by 1 degree Celsius. Okay, so it is given by this formula, that is Q is heat added is equals to C means constant for specific heat, M for mass, delta T means change in temperature. So Q is equals to Cm delta T is the formula for specific heat, where Q is for heat added, C is for specific heat. Letter C denoted specific heat, M denoted mass, and this is delta. Okay, this is delta T. Delta T means change in temperature. So in this table, specific heat is given of different material, and it is expressed in joules per gram degree Celsius. See guys, what is the unit of specific heat? The unit of specific heat is joules per gram degree Celsius. So liquid water specific heat is 4.18. Solid water, that is ice. Solid water means nothing but ice. Okay, it has specific heat is 2.11 joules per gram degree Celsius. In the same way, iron has 0.45, copper has 0.38, and lead has 0.13. Likewise, these are the some table and which shows about the specific heats of different materials. Next one is thermal expansion. See guys, thermal expansion means what? This thermal expansion is one of the physical property of material. So thermal expansion is a tendency of matter to change its shape, area and volume in response to a change in temperature. See guys, thermal expansion, let me tell you, expansion means expands in its physical properties. Okay, expands means expands in its physical size and all. Okay, so thermal expansion is the tendency of matter or substance to change its shape, area and volume in response to a change in temperature. As soon as your temperature is rising, your metal or material is expanded with that change in temperature. So it nothing but the thermal expansion property. Now temperature is a monotonic function. See guys, temperature is what? Temperature is a monotonic function. Now what do you mean by this monotonic? What is the meaning of this monotonic function? I have mentioned this in different color here. Please see. Monotonic function means nothing but a function which is either entirely non-increasing or non-decreasing. Okay, monotonic function means a function which is either entirely non-increasing or non-decreasing. Okay, of the average molecular kinetic energy of a substance. So when a substance is heated, the kinetic energy of its molecules increases. That is, delta L is equals to LO into alpha of T1 minus TO. Now see what it stands for. Where delta L is change in length, LO is the original length, alpha is coefficient of thermal linear expansion, T1 is the final temperature and T0 is the initial or reference temperature. So this is nothing but the thermal expansion of the material. Then next is thermal conductivity. See guys, this thermal conductivity is also one physical property of material which tells us that the amount of heat that flows per unit time through a unit area with a temperature gradient of 1 degree per unit distance. See guys, the amount of heat that flows per unit time. Okay, the amount of heat that flows per unit time through a unit area with a temperature gradient of 1 degree per unit distance. This is the formula for that. That is P is equals to Q by delta T. P is equals to Ka delta T by L, or K is equals to PL upon A into delta T. So what is this? Please see. P is the rate of energy transfer, that is in watts. Q is the energy transfers in joules. Delta T is change in time, that is seconds. K is thermal conductivity. Capital A denotes area of thermal conductivity. Capital L denotes thickness of material, and delta T denotes difference in temperature. So this is what all the thermal conductivity, which is expressed in watt per meter degree Kelvin. Okay, so this is about the various physical properties of materials. I hope this content is beneficial to understand you about the physical properties of material. Thank you.